Everybody is looking for innovative and sustainable building designs. Buildings are more than just bricks and mortar. They are carefully designed structures. Form-active structures take this a step further. They use their shape to handle the weight and forces upon them. This makes them strong and efficient. These structures are becoming increasingly popular in modern architecture. This is because they offer a unique blend of strength, beauty, and sustainability. Form-active structures are different from traditional structures. Traditional structures rely on heavy beams and columns. Form-active structures use their shape to distribute loads. This means they can be lighter and use less material. This makes them more sustainable and cost-effective. Form-active structures are inspired by nature. Think of a spider web or a seashell. These natural structures are strong and lightweight. They achieve this through their unique forms. Architects and engineers are now applying these same principles to buildings. This results in stunning and innovative structures. Form-active structures are the future of architecture. They offer a way to create buildings that are both beautiful and sustainable. As we move towards a more sustainable future, these structures will become increasingly important. Please like and subscribe for more insights into the future of architecture. The shape of a form-active structure is key to its strength. The form is designed to distribute loads evenly. This reduces stress on any one point. Think of an archway. Its curved shape allows it to support a lot of weight. This is done by transferring the load along the curve to the ground. This efficient load distribution allows for material efficiency. Less material is needed to achieve the same strength. This is a major advantage of form-active structures. It reduces the environmental impact of construction. Let's take the example of a cable-stayed bridge. The cables, the bridge deck, and the towers work together. They create a strong and lightweight structure. The cables carry the tension, the towers handle the compression. This efficient use of materials allows for impressive spans. Material efficiency is not just about using less material, it's also about choosing the right material for the job. Form-active structures often use materials with high strength-to-weight ratios. These include steel, concrete, and even fabrics. Form-active structures are not rigid. They are designed to move and adapt to changing loads. This flexibility is another advantage of these structures. It makes them more resilient to earthquakes and wind loads. Think of a tall building designed to sway slightly in the wind. This movement is controlled by the building's form. It actually helps to dissipate the wind's energy. This makes the building safer and more stable. This flexibility also allows for unique and expressive forms. Architects can create buildings that are both functional and beautiful. Form-active structures often mimic natural forms, creating a sense of harmony with the environment. The aesthetic appeal of form-active structures is undeniable. These structures are often visually striking. They become landmarks in their own right. Think of the Sydney Opera House with its iconic sail-like shells. It's a testament to the beauty and elegance of form-active design. Form-active structures come in various types. Each type uses different forms and materials to achieve strength and stability. Let's look at four main types: tensile structures, compression structures, shell structures, and cable-stayed systems. Tensile structures are known for their lightweight and flexibility. They use tension to maintain their shape. Think of a suspension bridge or a fabric canopy. The cables or fabric carry the load through tension. This creates a strong and lightweight structure. Compression structures rely on compression to resist loads. Arches, vaults, and domes are examples of compression structures. The weight of the structure is transferred downwards. This creates compressive forces that hold the structure together. Shell structures are thin, curved surfaces that distribute loads efficiently. They combine both tension and compression to achieve strength. Think of the Sydney Opera House or a concrete shell roof. These structures are known for their elegance and efficiency. Cable-stayed systems use cables to support a deck or roof. These cables are attached to towers or masts. Cable-stayed bridges are a common example. These structures offer a good balance of strength, stiffness, and cost-effectiveness. Section 5. Mechanics of form-active structures. To understand form-active structures, we need to look at their mechanics. This involves understanding load paths, equilibrium, and material behavior. Load paths refer to the way loads are transferred through a structure. In form-active structures, loads follow the shape of the structure. This minimizes bending moments and maximizes efficiency. Equilibrium is crucial for any structure to stand. In form-active structures, equilibrium is achieved through a balance of forces. Tension and compression forces work together to keep the structure stable. Material behavior is also important. The materials used in form-active structures are chosen for their specific properties. Tensile structures require materials with high tensile strength. Compression structures need materials with high compressive strength. The design of form-active structures requires careful consideration of all these factors. Engineers use sophisticated software to model and analyze these structures. This ensures their safety and stability. Section 6. Applications in architecture. Form-active structures are incredibly versatile. They can be used in a wide range of architectural applications. Let's explore some of these applications. Bridges are a classic example. Suspension bridges and cable-stayed bridges use form-active principles to span vast distances. These bridges are not only functional but also iconic landmarks. Sports arenas and stadia often feature form-active roofs. These roofs can cover large areas with minimal supports. This creates open and unobstructed viewing experiences for spectators. Cultural buildings, such as museums and theatres, also benefit from form-active design. These structures can create unique and inspiring spaces. The Guggenheim Museum Bilbao is a prime example of this. Pavilions and temporary structures often use lightweight form-active systems. These structures are easy to assemble and dismantle. They are ideal for exhibitions, events, and disaster relief efforts. Section 7. Advantages of form-active systems. Form-active structures offer numerous advantages over traditional structural systems. These advantages make them an attractive option for architects and engineers. Structural efficiency is a key advantage. By using form to distribute loads, these structures use less material. This reduces the overall weight and cost of the structure. Sustainability is another major advantage. The reduced material use translates to a lower environmental impact. Form-active structures are inherently resource efficient. Aesthetic quality is a significant advantage. Form-active structures are often visually stunning. They can create a sense of lightness, elegance, and movement. Flexibility and adaptability are also important advantages. These structures can adapt to changing loads and environmental conditions. This makes them more resilient and sustainable in the long run. Section 8. Limitations of form-active systems. While form-active structures offer numerous advantages, they also have limitations. It's important to consider these limitations before choosing this structural system. Design complexity is a major limitation. Designing form-active structures requires specialized knowledge and expertise. The analysis and engineering of these structures can be complex. Construction challenges are another limitation. Building form-active structures can be challenging. It often requires specialized labor and construction techniques. Maintenance requirements can also be higher for some form-active structures. Regular inspections and maintenance are essential to ensure their longevity and safety. Weather dependency is a limitation for some types of form-active structures. Tensile structures, for example, can be susceptible to wind loads. Section 9. At conclusion, the future of form. Form-active structures represent a fascinating evolution in architecture and structural engineering. They embody a harmonious blend of functionality and aesthetics. By harnessing the power of form, these structures achieve remarkable strength and efficiency. As we strive for a more sustainable future, form-active structures will play an increasingly important role. Their inherent material efficiency aligns with the principles of sustainable design. Their ability to create stunning and inspiring spaces enhances our built environment. Form-active structures are not just about building impressive structures, they are about creating a more sustainable and beautiful future. As technology advances, we can expect even more innovative and awe-inspiring form-active structures to grace our skylines. If you enjoyed this video, please like and subscribe for more content on architectural marvels and engineering innovations.